Hi everybody, check this out. Here's a really good set of practice questions, pretty much like what I would expect a quiz about right triangle trigonometry should be. We've studied some right triangle trigonometry in the last few weeks, and then another set of questions would come from the law of sines and cosines. But let's just talk about right triangle trigonometry. And that's the kind of quiz you could expect coming up pretty quick. There'll be one of each actually. Give serious effort on these questions. Check your own work with the video and submit a picture at Canvas as assignment number 49. I want to see the process. The process is more important than your answers to me. Here it tells me that triangle ABC is a 30, 60, 90. I'm judging by appearances a little bit here. I figure there's the 30. And angle A must have been the 60 on that 30, 60, 90. And it tells me that AB is of length 1. Also that triangle PQR is a 45, 45, 90. I'll mark it this way. That those are congruent. 45, 45, 90. And PQ is of length 1. Real quick before I tell you, assign the other lengths for those special right triangles. Surely the longer leg in that right triangle, 30, 60, 90 would have been the square root of 3. The hypotenuse would have been twice the short side, would have been 2. Those are things you have to have memorized. And this isosceles triangle, yeah, these are both going to be 1. If that was 1, then this would have been 1. And if you use the Pythagorean Theorem, you'd find that the hypotenuse is the square root of 2. These are ratios that we ought to memorize. And they allow you to do all kinds of things in a trigonometry class. For example, we're going to evaluate these various trigonometric functions on various angles. To do these questions, I would want to remember that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Any way you want to remember those letters in that order. Some old horse came hopping through our alley. There's lots of other stuff, but that's a way to remember those. And then this has to be the sine of 45 degrees. Not a problem. I go looking for a 45-degree angle, and I recognize that sine is given by opposite over hypotenuse, so I could use either of these 45-degree angles. I choose to use this one, angle R. The opposite over the hypotenuse would be 1 over the square root of 2. I know I'm not supposed to leave that answer that way, so I'm going to go ahead and rationalize that denominator. Don't want to change the value, just going to change the appearance. And that gives me the square root of 2 over 2 when I multiply by that number 1. And I say that is the value for the sine of 45, the square root of 2 over 2. Now what's the cosine of 30? Well, I have to find a 30-degree angle, and we got one. I have used cosine, which is adjacent over hypotenuse. Adjacent, square root of 3, adjacent to the 30-degree angle, and hypotenuse is 2. So that'll just be the square root of 3 over 2. Nothing to rationalize there. The denominator's already clean. And what about the tangent of 60? Well, how do you get tangent in the first place? Yeah, tangent's opposite over adjacent. Let's go find this 60-degree angle and do the opposite over the adjacent. So the tangent of 60 must be the same as the square root of 3. You can think of it over 1. So I'll try it with a calculator, but the tangent of 60 is going to be 1.732, the same as the square root of 3. That's a nice way to start such a quiz. I hope you know those things already, feel comfortable with that. And then we have a new street light being installed in the neighborhood, and we're using a support cable that must be attached 20 feet high on the lamppost. So it tells me that this distance has to be 20 feet. That's where the attachment is made. And staked to the ground, making an angle of 35 degrees of elevation. Okay. So using this sketch, it has to be how far from the base of the lamppost must the stake be driven. Here's that lamppost, and here's that stake being driven. I guess we're looking for this distance right there, aren't we? I'm going to call it D. We're going to find that distance. I will be thinking about SOHCAHTOA. I'm going to have to make decisions about sine, cosine, and tangent. And write that as many times as you need to. I wish I knew the adjacent length here. And I do know the opposite length when I think about this 35-degree angle. I know the opposite. I want the adjacent. And that's got to make me think about tangent. So I'll make a statement about tangent right here. Actually, kind of a long statement. The tangent of this angle, 35 degrees. according to my diagram, is opposite over adjacent, and that would be 20 over d. Now pull up my trusty calculator, turn everything on and clear it up, and figure out, well, what do you say the tangent of 35 is? Hoping that you're doing the same thing at this moment. And it tells me the tangent of 35 is 0.7002. 0.7002 over 1. The tangent of 35 is equal to this ratio, and the tangent of 35 is equal to that ratio. Therefore, those two ratios are equivalent. Now I got to think to myself, how am I going to get it? How am I going to get d out of that? What do I do with that proportion to find that distance? And it'll be 1 times 20 is equal to 0.7002 times d. So 20 divided by 0.7002. I'm just going to do that with my calculator, and I'll have that answer. 7 divided by excuse me, 20 divided by 0.7002. Try to see if I can make that show for you. And there we have it being about 28.6 feet. So I know that distance. That's a step in the right direction. 28.6 feet. How long must the cable be? And a reasonable exercise would be use the Pythagorean Theorem, and you can figure that out. That's a great little exercise, but I'm going to use trigonometry because that's what I ought to be doing right now. I would go with this number because I know it's given to be truthful. And I'm looking for the length of the cable, which is in fact the hypotenuse, isn't it? I'm going to call that H for hypotenuse. And that's what I could have called it C for cable, but I'm going to find the length that I've labeled as H. I know the opposite, and I wish I knew the hypotenuse. And opposite and hypotenuse gotta make me think about sine, doesn't it? Let's make a statement about the sine of 35 degrees. According to my diagram, the sine of 35 degrees is opposite 20 over hypotenuse H. Next thing, go to my calculator and figure out what it's going to tell me is the sine of 20. See if that'll work a little better. The sine of 35, I apologize. And here I see that the sine of 35 is 0.5736 over 1. These things both equal the sine of 35, therefore equal each other. What would you do to get h from that fraction, from this proportion? 1 times 20 divided by 0.5736. Let's do that together and agree on that answer. 0.5736. So I think that must have been 34.9 feet long. If I didn't want to bore you to death, I'd use the Pythagorean Theorem and see if it worked out pretty cleanly. I can't help it, I'm going to do it right away. What if I would have gone with 20 squared plus 28.6 squared? Would have given me this number. And had I taken the square root of that, that would have told me, oh goodness gracious, let me go find my error. If I would have taken the square root of that, let me delete that. That would have told me 34.9, which is pretty close to what we said, huh? So I like the Pythagorean Theorem. I just had to touch base with you there. Let's go to this next one. A 24-foot ladder. There's it is right there. That's 24 feet, I figure. Is set against a wall, and the base of the ladder is 5 feet from that wall. This distance must be that 5 feet. What angle would the ladder make with the ground? All this is right triangle stuff. I'm going to decide if I'm going to use sine, cosine, or tangent. To find this angle, what do I know? The adjacent side? Yeah, that 5 is adjacent to the angle that is labeled as alpha that I care about. And I know the hypotenuse, and adjacent and hypotenuse should be making me think about cosine. Let's make a statement about the cosine of that angle. The cosine of alpha is known to be adjacent over hypotenuse. That'd be 5 over 24. And what I got to do to figure out about alpha is arc cosine both sides of this equation. Alpha will be the arc cosine of 5/24. You can make that a decimal and try it that way, but you need not. I'm just going to do it this way. Arc cosine of 5 divided by 24. Oh, I'm sorry. Make it so you can see it. Arc cosine of 5 divided by 24. And now I'd say that that angle must have been pretty close to 78 degrees. If I round things to the nearest tenth, I'd have to call that 78. So now we know that angle. How far up the wall does the ladder reach? There's another place where we could have used the Pythagorean theorem, but let's hit it with trigonometry first and maybe check it with the Pythagorean theorem. So, if I wanted to know this length right there, calling it h for height. Both of these numbers are given. I could go with the height compared to the hypotenuse. That would be the opposite over the hypotenuse, using that 78-degree angle. Let's see what comes of that. That was a little bit of a rounding thing, but it's pretty close to just right. So this is going to be nice. I wish I knew the opposite, and I do know the hypotenuse, so I'm going to say the sine of that 78-degree angle is equal to the opposite. That's the height of the ladder, this height, over the hypotenuse, 24. Can I ask my calculator about the sine of 78? It tells me that the sine of 78 is 0.9781. 9781 over 1. And I stare at this proportion and decide, am I going to be multiplying or am I going to be dividing? And clearly since 1 times h, it'll be just h, it'll be this product, won't it? 0.9781 times 24. 81 times 24. And I find that to be 23.5 if I round to the nearest tenth. So the height ought to be 23.5 feet. I'm going to hit that with the Pythagorean theorem and just see how it comes up. Seems like it's a nice idea. I'm going to go with 23.5 squared plus 5 squared gives me that number, and if I took the square root of that, what did I do silly there? Clear this. I'm going to take the square root of 577.25. That tells me that it should have been 24-foot ladder, huh? Yeah, pretty close. I'd round that to the nearest tenth and call it 24-foot ladder, and it works for me. Thinks I'm getting this stuff right. Let's go to that second page. A little more right triangle trigonometry. This is a ramp. It has an elevation of 6 degrees. So theta there is 6 degrees for now. This ramp with an elevation of 6 degrees is 70 feet long. That's 70 feet. How much higher is the elevated end of the ramp than the other end? I want to know what this height is right here. I wish I knew in terms of this angle, I wish I knew the opposite, and I do know the hypotenuse. So put a little SOHCAHTOA on it, figure out which trigonometric function we're going to use. If you want to know the opposite and you know the hypotenuse, it'll have to be sine. So sine of 6 degrees equaling opposite, I'll call that the height, over the hypotenuse this time, which is known to be 70. Then I'm going to figure out what the sine of 6 degrees is with my calculator. I'm going to calculate the sine of 6 degrees. This tells me that the sine of 6 degrees is 0.1045. over 1. Those things are equal, so I got a proportion I can solve. 1 times the height will be this product, won't it? So just 0.1045 times 70. I'll go with the number I already had in my calculator, multiply it. Let me clear that stuff right away. And just say times 70. So that would be pretty close to what you get, also about 7.3 feet high. So the height 7.3 feet. But then, through this question, because some things I've learned recently or stumbled across, what if the elevation would be needed for that 70-foot ramp to be twice as high? What angle of elevation would be needed so that it would be twice that high, so that the height here is 14.6 feet high? Would it be twice that angle? That's kind of what I'm wondering. Let's see how that works. What would this angle have to have been if instead of the height that we had before, it was twice that high, 14.6 feet? What would you know about this angle? I know about the sine of that angle, huh? Because I know the opposite and the hypotenuse, and that'd be about 14.6 over 70. If I want to know about that angle theta, it would be the arc sine of 14.6 over 70. And that's something I just got to do with my calculator, and I'll know the value for theta. Arc sine 14.6 divided by 70. Checking to see I got it correctly labeled there, and I'd say, well, yeah, it'd be about a 12-degree angle, wouldn't it? Isn't that interesting? About a 12 point, yeah, just to call it a 12-degree angle. I don't think that would work forever, but a 6-degree angle got me that high, and to be twice that high would have taken a 12-degree angle. I find that to be interesting. Let's play some more. A right triangle ABC has legs of length AC is 4, and BC is 2 times the square root of 5. Give the length of the hypotenuse. Now, that'll just be a little time for the use of the Pythagorean Theorem, wouldn't it? We've been practicing with these kinds of numbers happily. 4 squared plus 2 square roots of 5 squared ought to equal AB squared. Let me write it that way. And 4 squared we know to be 16. What happens when you square that 2 square roots of 5? You square that 2, you get a 4. You square the square root of 5, you get a plain old 5, and 4 times 5 is going to make that be 20. So you square 2 root 5 and it becomes 20 is equal to AB squared. Those add up to 36, don't they? And if AB squared is equal to 36, I'm convinced like you are that AB would have been 6. Glad we practiced that kind of stuff earlier, but then it says, show the process as you find the measures of the acute angles in this right triangle. You can do it a couple of different ways, I'm sure. I kind of like sine. What would be the sine of angle A? Well, sine would be opposite over hypotenuse, and that'd be 2 root 5 over 6. If I want to know the measure of angle A, I would have to arc sine this amount. The arc sine of 2 square roots of 5 over 6. I'll do that with a calculator immediately. Second, sine. Now, getting that 2 square roots of 5 is a little bit fun. I gotta stick that 5 in place there. Close those parentheses. Divided by 6. Check what I've got written there. I'm arc sine 2 root 5 over 6. I think I've done that correctly. Hit enter, and it tells me that's a 48.2 degree angle. Hold that thought. Let's go for angle B. We'll use trigonometry, then we'll make sure that they were adding up to 90 together. So let's use something besides sine. I like sine, but let's do something. I'd say that what's the tangent of angle B? You could do sine, cosine, or tangent. I'm going to use tangent, and you can use whatever you like. Let's see if we can agree. What would be the tangent of angle B? Well, since tangent's opposite over adjacent, tangent of angle B would be 4 over 2 root 5. I know that because 2 goes into both of those. That'd be 2 over the square root of 5. You go ahead and rationalize that denominator and multiply by square root of 5 over square root of 5. I'm pretty sure you'll come up with 2 square roots of 5 over 5. You could enter this as you arc tangent the amount, or you could enter this one. Both of them would work just fine, I'm sure. I'll go with this guy because it's better form. If I would like to know the measure of angle B, it will equal the arc tangent, the angle whose tangent is 2 square roots of 5 over 5. Let's witness that. Arc tangent 2 square roots of 5 divided by 5. I think I got that properly written. And that tells me 41.8 degrees. These are looking pretty good for being complementary, aren't they? 41.8, I'm going to be positive about that. 41.8 plus 48.2. Yeah, those are adding up to 90. And I'm glad they had to, because these are the acute angles of a right triangle. They're going to have to be complementary. I'm feeling comfortable with that. One more thing to look at in the idea of right triangle trigonometry. We talked about angles of depression. Let's work with one of those. Here's Xavier up on a cliff 110 feet high. That's how high that cliff is. He's watching his friends Paul and Quincy. Here's Paul and there's Quincy, and they're sailing away from him, leaving him on that island. They make angles of depression. Let me look at Quincy's angle of depression first. And Quincy's angle of depression here is 8 degrees. And what we got to recognize is the water would be parallel to this line that is horizontal. Therefore, this 8-degree angle would match with this angle being 8 degrees. We'll be using that angle probably. And the angle of depression to Paul is 14 degrees. And if that angle is 14, then this one would have been 14. Find the distance from each of Paul's friends to the base of the cliff. I should have said from Xavier's friends. Find the distance from Paul to the base of the cliff and from Quincy to the base of the cliff. Let's work with that 14-degree angle and find this distance right there. I guess I could call it BP. I do know the opposite length. I wish I knew the adjacent length. So going through your SOHCAHTOA, would you use opposite and adjacent going to be tangent? The tangent of 14 degrees is given by the opposite 110 feet over the adjacent. That's what I want to know. I'm going to call it BP. I'll continue with what is the value of the tangent of 14. Which is what you're also doing, I expect, 0.2493. Over 1. And then when you stare at this proportion, you got to decide, are we going to end up multiplying or are we going to end up dividing? And it's pretty clear to me it's going to be 1 times 110 is equal to this product, so it'll be 110 divided by 0.2493. Let's make that happen. 110 divided by 0.2493. So that distance would have been 441.2 BP. 441.2 feet. Now, how far is Quincy from that cliff? For the same kind of reasons, we're going to use the tangent again, but this time we're going to work with a tangent of 8 degrees. Tangent of 8 degrees is given by the opposite over the adjacent. Let's call that adjacent BQ this time. So opposite 110 feet over adjacent BQ. What else is the tangent of 8 degrees equal to, he wonders? And the calculator lets me know. Tangent of 8 is 0.1405 over 1. Again, upon inspection on that on this proportion, we're going to just cross multiply, and it's going to be, oh, we'll divide here, won't I? Yeah, 110 divided by 0.1405. Divided by 0.1405. And that yields 782.9. That's BQ. 782.9 feet. How far ahead of Paul is Quincy at the moment? So Quincy's here, Paul's there, and we want to know how far ahead of Quincy is as they sail away. It should be the difference between these couple of numbers, huh? If I know the distance from